Hello and welcome back everyone to this series of videos on making a game in JavaScript. This is going to look like this. Today's video is going to be a fairly short one. So in the last episode we added a level editor to our game. However, the player can't really interact with the levels that we build. They can just walk through walls and pass over objects without interacting with them. So in this episode we're going to fix this by adding some collision detection to the game. So what is collision detection? Well, it's where we detect if two objects in the game have intersected. Obviously, we can use this to see if the player is trying to walk through a wall, and stop that. But we can also use it to interact with objects, say picking them up. And in the future, when we add monsters to the game, they can also use collision detection to interact with the environment. How can we do this? Well, fortunately, there is a simple algorithm that will work for our game. It's called the Axis-Aligned Bounding Box Algorithm, or AABB for short. What does that mean? Well, it means it only works for boxes, which in a 2D game like ours means rectangles. In our game, the map tiles are already squares, so that works out nicely. And I think it will be fine to approximate the hero and the other objects in our game as rectangles. The boxes also need to have aligned axes, i.e., they both need to be aligned like this. The algorithm doesn't work if the axes of the two boxes are not aligned, like this. So the way the AABB algorithm works is very clever and efficient. So let's just say we have two boxes. We've got box A and box B. And the question we want to know is, does box A intersect with box B anywhere, right? So it might intersect like this, or like this, or like this, or like this. We don't care. We just want to know, does it intersect or does it not intersect? So here's some examples of it not intersecting. So what we can do is, let's just say we draw an infinitely long line here on the right hand side of B. So what we can do is first is we can do a test and we say, is A entirely to the right of B? So is it over here somewhere, or like over here or over here? So not like this or not like this, but if it's entirely over here to the right of B, then we know it can't possibly intersect with B. So we're done, right? We can say there's no intersection. And then we just go, okay, well, let's just do the same test, but we'll do it to the left of B, right? So we go, is A entirely to the left of B? And if it is, once again, okay, there can't possibly be an intersection. We're done. And now we just kind of do the same thing on the top and bottom, right? So we go, okay, is A entirely above B? Okay, then there's no intersection. And then we go, is A entirely below B? Is it down here somewhere? Well, then there's no intersection. Now, if we do all four of those tests, and they're all false, then that means A must intersect with B, right? We don't know where. It might be here, or here, or here, or here. But we know that A must intersect with B if all four of those tests were wrong. So that's how we get our answer. This turns out to be fairly trivial to implement in JavaScript. It looks like this. We have two bounding box objects. Each bounding box object contains the X and Y coordinates for the top left corner of the bounding box, as well as the height and width of the bounding box. Then we test all four of the conditions like so. First, we take bounding box B's X value and add it to its width. This gives us the first line we want to test against. We just see if bounding box A's X value is greater than this, and if so, we know that A is completely to the right of B. Let's store that in the value called A is to the right of B. We use similar logic to do the other three tests. Now, we OR all of these results together. This tells us if any of them were true. Remember, if any of the conditions is true, that means there was no collision. So we want this function to tell us when there is a collision, so we just invert the result. So let's go ahead and use this in our game. First, we want to stop the player from walking through walls. It really kills the immersion. Over here, we have the code that moves the hero. Before we let the player move the hero, let's do a test to see if the hero's new location would cause a collision. If so, we won't allow the player to move the hero. So we will create a new bounding box that is the hero's anticipated location, and we need to test it against the map tiles. We could test against every tile in the map, but that feels a little wasteful. we can take advantage of the fact that we know the hero's location and size to do things a little more efficiently. We know the hero is smaller than the size of a tile, and that means we actually only have to test against 4 tiles. We take the X and Y coordinates that give the top left corner of the hero's new bounding box, and we test the tile that they land in. We then only need to test the tile to the right, the tile below, and the tile below and to the right. These are the only tiles the hero could possibly intersect with. And here we can see it in action. I temporarily added some green and red squares to show the bounding boxes that are being tested. Note that we only bothered to test tiles that are impassable. Also, we short circuit as soon as we find a collision. So if the hero intersects with multiple impassable tiles, we don't test all of them. Looks like it's working well. So how about the objects? There are some objects, like this big rock, that we will want to make impassable. For other objects, we want the hero to be able to walk over them, but we still want to know if there was a collision, since we will need this information later to allow the hero to interact with the objects. In the case of the objects, there isn't really an obvious efficient way to know which ones we need to test against. So let's just loop through all of the objects and see if there are any collisions. Alright, so that looks like this. It's a bit meh. It seems like the player should be able to get closer to that rock. If we wanted to be fancy, we could give each object its own custom bounding box. But I want to try something a little simpler first. So I just scaled down the size of the bounding box by 40% for objects. I think this is a good enough solution for now. We can see this looks pretty good when the user goes up to the big rock. For the other objects, we can use a little console logging to see when they are passed over by the hero. I think this is going to work. Okay, so that was just a quick one today. You can see for a simple 2D game like this, collision detection is actually pretty easy to add. It really feels like we're making some progress on this game now that we've got collision detection in it. So don't forget to like and subscribe, because next week things will be getting a little animated.